Hello everybody, welcome back. In today's example, we were continuing on with 2.4, the sine and cos ratios. We're looking at example 2. Alright, so in this one it says use sine or cos to determine the measure of angle, following angles. So we have G or H. So you can pick either one first. I'm going to use find angle G because it asked for it first. So if I'm talking about angle G, 6 would indeed be the adjacent side and 14 would be the hypotenuse. So if I'm talking angle G, that means I have to use the cosine ratio. All right. So cos G, we can replace that. You can put angle G or G. Just G is fine. The adjacent side, remember, is going to be 6, and the hypotenuse is going to be 14. Okay. So we can replace those values there. Alright, I'm going to copy that just so I have that original there for you. So remember that's going to be G, right? And the adjacent side is the one that's attached to that angle, right? 6. And the hypotenuse is always across from the right angle, so across from K is 14. 14 is indeed the hypotenuse. Alright, there's no need to change this to a decimal. Some people will. I just leave it as is. And then we're going to calculate the angle. So if you do recall, then we just put G is equal to, right? Good. And you can use angle G if you want at this point. It doesn't make a difference, honestly. Maybe get in the habit of showing that just for the provincial so that they don't think it's a measure, but angle G is equal to, and then what we're going to do is we're going to insert the inverse cos. So at this point, when we're looking for the angle, remember it's the second function button on your calculator. You're taking the inverse of that. And it'll usually open up the bracket on your calculator depending on your calculator. So I put 6/14ths in. And then I'm going to calculate that. So I got angle G is going to be equal to, so I'll punch that in my calculator. Remember, second function, cos 6 divided by 14, close your bracket, equals. And it's saying to the nearest tenth of a degree, so I'll write down what I have. I go 3 places after decimal, more than enough. And remember, it's to the tenth of the degree, so that means that the 2 is going to leave the 6 at a 6. So angle G is equal to 64.6 degrees. All right. Now, there's a couple ways you can calculate the angle H. We know that 3 angles in a triangle add up to 180 degrees, so we know this is 90. We have the calculate this at 64.6, so that would be the difference, and that would just simply be 25.4. Or we can use the other ratio, which we know is the sine ratio, to calculate that. Either one's fine. I would just recommend doing what I just said before, subtracting 64.6 either from 90 or 180 with the 90. It doesn't make a difference. Or I can show you that calculating the sine is going to give you the same thing, right? So sine of H, angle H is equal to the opposite of hypotenuse. All right. Grab that angle back, sorry. Do angle H this time. Oh, sorry guys, I don't know what's going on. There we go. So opposite of H is 6/14. So remember this opposite, not adjacent, obviously. So we'll calculate that. We'll copy. And the opposite would be 6/14. So yes, you're right. The ratio is still the same, but you're doing a different trig function on there. You're doing the sine. So in this, with respect to angle H, 6 is actually the opposite side, right? So you get angle H is equal to the inverse sine of 6/14. Angle H is equal to, and we'll put that in our calculator. I know we've predicted that it's going to be 25.4, subtracting that from 90, or subtracting 90 and that from 180. And then we get second function sine 6, it opens up your bracket, so the inverse sine of 6 divided by 14, close bracket, enter, and indeed we get 25.3769, so we know that angle H is equal to the 7 rounds the 3 up to a 4, so it is indeed 25.4. So remember, you could have just subtracted, because remember the 3 angles do add up to 180, or G and H add up to 90. It's up to you, however way you want to look at it, right? But remember, the 3 angles in any triangle add up to 180, or the other two angles, not including the right angle triangle, in a right angle triangle, add up to 90. Either way you want to look at it. Okay. So there's a check your understanding question. It's done very similar to what we just did, so you can try that on your own. Okay. So next we're going to look at some terms you need to know. So we already did the angle of inclination. That's the angle of inclination is the line. Is the angle made between the line and the horizontal line which it intersects. That was the one we did with the roof, the solar panels, if you remember. Angle of elevation is very similar to that, but it's a line of sight that's made with the horizontal as you look up towards an object, and then the angle of depression is the line of sight made with the horizontal as you look down towards an object. Okay. Let's look at example 3 based on the information that we just received there. And I recommend drawing a diagram when possible. So I've drawn my diagram on the page there. It says water bomb is flying at an altitude of 5,000 feet. So an altitude is a horizontal line for a plane that it makes with the ground. So X will be the ground directly below the plane. A is where the plane is at, and the plane's radar shows that as 8,000 feet from the target site. So R there being the target site. Okay. What is the angle of elevation of the plane measured from the target site to the nearest degree? So there's the target site, R. There's the plane, A, airplane, I guess. And X is the altitude dropping from a vertical line from completely beneath the plane to the ground. Again, we assume obviously that the ground is is horizontal, right? Those are assumptions we have to make. So the plane to the ground is 5,000 feet, and the plane to the target site is 8,000 feet. So it's approaching, right? This plane is heading towards this site, right? It's going to drop the water, okay? So it has to know when to do so. And we're going to calculate the angle in doing so. All right. So if this is a reference angle or angle of elevation, if you wish, right, or inclination, it can be either one really. So if we label our triangle, opposite of R is 5,000 and the hypotenuse is 8. So you got to think back, do I use sine, cos, or tan even? Well, we know that when we have opposite over hypotenuse as a ratio, this is when we use the sine ratio. So now what we can do is we can add in our variables and solve for the angle R. So we know we're looking for R, so we're going to replace theta with R. The opposite side, like I said, is the opposite side of angle R, which is 5,000. The hypotenuse is opposite of angle X, or the right angle, and that's 8,000. So then what we're going to do is we're going to calculate that value. So remember, now we're going to do the inverse function on our calculators. So that's going to be R is equal to on our calculator, we punch in sine -1, so that the second function. Open up your bracket, 5,000 divided by 8,000, close your bracket, okay, and that's going to give us angle R, or R you can say, or angle R, it doesn't make a difference. So we go inverse sine of 5,000 divided by 8,000, and we get 38.6821. I just wrote in a few different numbers, right? It doesn't make a difference. And then you go back and you look to see if they've actually asked you to round it to a certain value. In this case, it's to the nearest degree. So that means a 6 is going to round the 8 up to a 9. So it's going to be 38 degrees. Okay, so it's going to be 39 degrees. My apologies. All right. And we can answer with a sentence. So what is the angle of elevation of the plane measured from the target site to the nearest degree? The angle of the elevation of the plane is approximately 39 degrees. And that's it. That's all it's to it. There's a check your understanding question. It's done in a similar fashion. All right. I recommend a diagram. If there's no diagram given, that's where you have to come up with a diagram for your questions. It'll really help you. All right, and the homework is found on page 95 of your textbook. So I would like you to try numbers 4 through 6 and 9 through 15. In the next class, we'll head to 2.5, and we'll use the sine and cosine ratios, not only to calculate the angles, but to calculate the lengths. So thanks, everybody, and I hope you're enjoying the videos. Any feedback would be great in class. Again, this is just another resource to help us tackle some of these problems. I hope everybody has a great day, and we'll talk again soon. Thank you.